So today we're going to look at the age of the solar system. This is the first of a series of videos that will cover pretty much every area of science that relates to evolution, and will show that the data does not fit the evolution model. Instead, the data fits the flood and creation model better. Let's start out with some definitions. What is science? According to Britannica, it is having to do with unbiased observations, systematic experimentation, seeking after truths or fundamental laws. Here is a different one from the Merriam-Webster definition: a system of knowledge covering general truths or the operation of general laws, especially as obtained and tested through the scientific method. We'll talk about the scientific method more as we go on. And this from the Oxford Dictionary. It's the testing of theories against evidence obtained, and that's what we want to concentrate on. Because science is supposed to be observable, testable, repeatable, and falsifiable. Now, creationists are honest enough to admit that creation is not observable. It happened in the past. Therefore, it's not testable. It's certainly not repeatable by us humans, but we can look at things at the data and see if it is falsifiable. If evolutionists were equally honest, they would also admit that evolution is not observable, it's not testable, and it's not repeatable, because if evolution really happened, it was also in the very distant past, but it can be checked against known data or evidence, and that's what we're going to do. To summarize what we've covered so far, science is supposed to be unbiased observations, it's supposed to be systematic experimentation, it's supposed to be truths and fundamental laws, we're supposed to test theories against evidence, and we're supposed to use the scientific method. So here are the essential assumptions for the theory of evolution. It is that the universe and the solar system all happened naturally. There was no supernatural act of God involved at all. It all happened naturally with natural laws. That the Earth is billions of years old, that life began from non-life about 3.8 billion years ago, that life evolved from simple to complex, that humans and apes evolved from a common ancestor, and that a global flood never happened. This first video that we're going to have today on the solar system is going to blow those first three right out of the water, because we're going to see that the solar system didn't happen naturally, that the Earth is not billions of years old, and that life couldn't have begun 3.5 billion years ago. Another principle we need to introduce is the principle of uniformitarianism. This is the logic upon which evolution is based. And the definition is the belief that all processes have worked the way they do now, gradually over a long period of time instead of in compressed periods. Here's an example of uniformitarianist thinking. This man is walking at 3 miles per hour. His house is 60 miles away. So the uniformitarianist conclusion, therefore, he has been walking for 20 hours. But uniformitarianism ignores certain other very real possibilities, such as, did he come from his house? Did he run some of the way? Did he hitchhike part of the distance? That would certainly speed him up. Either one of those. Did he stop and rest along the way? That would slow him down. Is he tired now and walking at a slower speed? Which would also have to factor in a slower overall time. So the idea upon which creation science is built is called catastrophism. And it is a belief that gradual processes have been interrupted by the effects of huge natural catastrophes, which would throw off uniformitarianist thinking. Here is the scientific method. We start at the top middle. We make observations and we research. We ask questions. Then we construct a hypothesis. Then we make testable predictions or experiments, and we've already established neither evolution nor creation lend themselves to experiments, so we can make testable predictions. Then we see, does the data fit the predictions? If yes, we go on to develop general theories. But if no, we should go and refine, alter, expand, or reject the hypothesis. And this is what the evolutionary scientists are unwilling to do. They're so committed to their dogma of evolution that they can't go back and reconsider things. There's another principle in science called Occam's razor. It basically states that simpler explanations are generally better than more complex ones. While we look at today's data concerning the solar system, we're going to see that a lot of evidence does not fit with the prevailing theory of the age of our solar system, or that it came about by strictly natural means. The simpler conclusion would be that these planets were individual creations and are only thousands of years old, not billions of years. A very famous science philosopher in the last century, a man by the name of Karl Popper, said the central idea of falsifiability is that a scientific theory can never be proven true. Instead, science progresses by developing theories that are testable and can be disproven or falsified by the evidence. What does that mean? If I propose a theory that all swans are white, seeing a bunch of white swans does not prove my theory, it's just consistent with my theory. If I see some more white swans, that still does not prove my theory, it just means that that's consistent with my theory. And it doesn't matter how many white swans we find, that still doesn't prove my theory. It's only consistent with the theory. But even if I find a single swan of some other color than white, it's sufficient to disprove my theory that all swans are white. So you see how that works. Another thing that Karl Popper said is one contrary observation is often sufficient to falsify a theory. So let's look at evolution versus creation compared to the known data. Now, since we're talking about the solar system and space, we should note that over the last decades, humanity has explored outer space with lots of probes. But every time we send out space probes and find out what's really there, science theories have to be revamped because they discover facts that don't fit with the theories. This is a question we'll ask over and over again. Which one is real science? The data or the evidence must conform to the theory. If it does not, just adjust or ignore the data? No. Or the theory must conform to the data. If it does not, adjust or abandon the theory. Now I'm going to make a very radical claim. Evolution and creation are both religious beliefs. But which one fits the data best? How old is the solar system and the Earth? If we go from a creationist point of view, the Earth was created in 6 days. There is a scripture in 2 Peter that says, one day is with the Lord as 1,000 years, and 1,000 years as one day. So even if we took that to be literal, and we said, okay, the Earth was created in 6 days, let's grant this creation period of 6,000 years. And since the fall of Adam, the Bible is pretty good on nailing down dates and so on. It would be around 6,000 years since the fall of Adam. So the total amount of time that a creationist, just giving the most amount of time possible, depending on different points of view, is 12,000 years. Compare that to the naturalist or the evolutionary view of things as about 4.5 billion years. There's a big difference between those two. And one thing we have to remember, if the Earth isn't billions of years old, evolution can't have happened. Now I'll use this visual. In the upper left, there's a little tiny white dot. That represents 12,000 years. And if that dot represents 12,000 years, then all of those red dots together still only equals 1 billion. Massive difference. When we talk about numbers, it's very abstract and we don't quite often grasp how much of a difference there is. But here we can see it. And that's not even the 4.5 billion years that the solar system is supposed to have for an age. There's really only two choices. Either the solar system and all of its bodies were made naturally by strictly material processes over billions of years, or the solar system and all its bodies were created individually and only a few thousand years ago. We're going to look at things today and see which conclusion we can arrive at. Which model fits the data best? How was the solar system formed? Well, this is the most popular model on how the solar system came to be. Initially, there was a big cloud of dust that began to coalesce. The cloud drew together, and when there was a critical mass of matter at the center, the sun was born, and the remaining material aggregated into the planets and the large asteroids. And that's the evolutionary model. Overall, it sounds possible, but there are lots of facts, especially new facts that we're discovering with these space probes, that don't fit this model. For instance, if the planets formed from leftover material from our sun in this spinning disk of material, it should have acted like a centrifuge. Now, a centrifuge is an item that's used in certain industrial processes to get suspended materials to organize themselves. And by spinning this test tube, for instance, it will organize all of those different particles into discrete layers of particles according to density. So if the planets evolved from a spinning disk of material, there should be some progression by either size or by composition or by density. And if not, then it would indicate maybe they were individual creations. If we got our solar system from a spinning disk of material, there should be some logic as to planet size. But you can see there clearly is not. We go really small, little bigger, smaller again, then way big, then a little smaller, and then smaller and smaller. That is not any kind of logical progression in size. Another thing is planetary rotation. The sun spins in a certain direction, and all of the planets spin in that same direction, which does make it sound like that spinning cloud of gas could be possible. But there are 3 planets that don't spin that way. Venus spins exactly the opposite. How did that happen? Pluto also spins pretty much the opposite. And Uranus is more than a right angle different from all the rest of the solar plane and the rest of the planets. That doesn't make any sense. And what about Uranus? Well, it's possible that Uranus could have been tipped on its axis by a comet or some other gravitationally large enough body, but Uranus has 28 moons, and they still rotate the planet around its equator. So if something came and tipped Uranus, it would have thrown those moons out of orbit or had them crash into the planet, or in any case, they wouldn't be spinning on the same axis as the planet. So that doesn't make sense. Another thing that's difficult is if the axes of the planets are not the same, they should be at least in a progressive pattern. So we have Mercury that's on the same axis, the spin of the sun. Venus is just a little bit off, and Earth is just a little bit more off. So we're starting to see a progression. And then Mars is just a little bit different than Earth. It's almost exactly the same as Earth. And then Jupiter goes back to almost zero, only 3 degrees. And then Saturn is 26. And then Uranus, like I said, is 98 degrees going the other direction. And Neptune is 29, and then Pluto is 60. So it's all over the map. There's no progression as far as the tilt of the axes in regard to the sun or the solar plane. And why is the rotation or the length of a day on a given planet not the same, or at least in a progressive pattern? We have the Earth, that's the third one from the left there, and we're showing that little block representing 1 Earth day. So Mercury spins very slowly. That's really interesting. And then Venus is way slower. But then we go the other direction, and Mars is almost the same as Earth. And then Jupiter, even though it's many dozens of times more mass, it actually spins faster than the Earth. And so does Saturn. And Uranus is a little bit slower than the Earth, and so is Neptune. And then Pluto is backed up to 6.5 days. This is not making any sense. If you look at this model of how the solar system came into being and how can planets be rotating in different directions from others, have axes of spin at all different angles, rates of spin that don't make any sense. If they are separate creations, however, there's no conflict. If we look at the number of moons, Mercury has 0 moons, Venus has 0 moons, Earth has 1 moon, Mars has 2 little moons, Jupiter has 95 moons. That's the biggest planet. So you'd kind of expect Jupiter to have the most number of moons, but it doesn't. That honor goes to Saturn with 274. We're going to talk more about those moons because they're really bizarre. And then we look at Uranus with 29 moons, and they also have some unusual things about them that we'll talk about today. And then finally, Neptune with 16 moons. And if we wanted to include Pluto, it has 5 moons of its own, even though Pluto is actually smaller than Earth's moon. So just keep that in mind. That's why it was demoted and not any longer considered a planet. If we look at all these anomalies, the planets are rotating backwards to the sun and most other planets. Uranus rotates at almost a 90-degree angle from the rest, but has 28 moons that rotate with it, ruling out tilting by a passing body. The planetary axis tilt is not the same and follows no pattern. Speed of planetary rotation also follows no pattern. And there's no progression of size or pattern of size or rotation or number of moons. It's not an issue if each planet was created separately. Which is more credible? Planets have different sizes, different rates of rotation and directions, different axes, and different numbers of moons, all from one spinning disk of matter. Or planets have different sizes and rates of rotation and direction and different axes and number of moons because they were created individually. Now, this is the accepted astrophysical science explanation of the life cycle of a star the size of our sun. Here we find ourselves now, about 4.5 billion years since the birth of our sun, and our sun is stable. So this is life as we know it. But about 2 billion years from now, the sun will expand and it will heat up, and Earth's oceans will boil away. So that's it for life on the Earth. And then 3.5 billion years from now, Earth will resemble Mercury or Venus, but Mars may become habitable because the sun will get hotter. And then about 5.5 billion years from now, the sun will be in what is called its red giant stage. It will actually expand so much that it will engulf the Earth. So goodbye, Earth. But the moons of both Jupiter and Saturn could become habitable. So this is all accepted astrophysics science, and nobody says that this is wrong. But if we look backward in time on this accepted solar timetable, we have a different problem regarding the origin of life on Earth. If we go back to when the life was supposed to begin on Earth, our sun was so faint that Earth was frozen without any liquid water. And without liquid water, all of the theories for the development of life, they just don't hold up. Now, they even have a name for this. It's called the faint sun paradox. And this is not something that creationists thought up. This is something that regular evolution believing astrophysicists have discovered and cannot figure the solution for. They've come up with a few weak ideas on how this might be different, but none of them really hold up to serious examination. But this is not an issue if the Earth is only a few thousand years old, because the sun would basically be the same. Which is more credible? The faint sun paradox, 3 to 4 billion years ago, our sun would have been too cold for the rise of life, but it happened anyway? Or only 6 or even 12,000 years ago, the sun would be similar to today, posing no problem for the creation model. If this is how big the sun appears from Earth, then this is how big it would appear from Jupiter. As you can see, a lot farther away, providing a lot less warmth. Here we have a chart of the mean temperatures of the planets in our solar system, meaning if you took all the temperatures from one pole to the equator to the other pole and averaged them out, that's what you get as a mean temperature. Notice that Earth is 59 degrees because we have some really cold areas and we have some warm areas. So it all averages out to 59 degrees. The hottest planet in our solar system is Venus because it has an atmosphere that keeps that heat in. Whereas Mercury, which is even closer to the sun and should logically be warmer, but because it has no atmosphere and because it turns very slowly, the dark side of Mercury would be very, very cold, being 50 or 60 days without any sunshine on it. And so you average those out and you only get 333 degrees, which is still too hot for any life that we know of. Going farther away from the sun, the mean temperature on Mars is a minus 85 degrees Fahrenheit. That's pretty chilly. And then you go farther, you've got Jupiter at minus 166 degrees Fahrenheit. And then you go farther and you've got Saturn. And we're going to stop there and we'll talk about other planets. But if you stop and consider the mean temperature on Jupiter and Saturn, this is really cold. Please note that those are colder than any natural temperature anywhere on Earth. So their mean temperature is already colder than any place on the Earth. It turns out both Jupiter and Saturn radiate more heat than they get from the sun. They're actually emitting heat more than they get from the sun. But because they're so far away from the sun, if they were billions of years old, they should be frozen solid. Think of this in a backwards sort of way. You put an ice cube in a glass of water, that ice cube is going to lose some of its cold to the water around. It will disintegrate. Same thing with heat. Over time, heat dissipates. Over billions of years, there should be no heat on either Jupiter or Saturn, especially as far away from the sun as they are. They should be frozen solid. So Jupiter's volume is 1,321 times that of Earth, but its gravity, which is a function of its heat generating capacity, is only 2.4 times that of Earth. For all that volume, it's still only 2.4 times. Therefore, it shouldn't be able to generate that much heat after billions of years. Likewise with Saturn. Saturn's volume is 764 times that of Earth. But Saturn's gravity is actually less than that of Earth's. In spite of all how big it is, its gravity is actually less than Earth's, and therefore its ability to generate heat. Therefore, it should not be able to generate that much heat after billions of years. This is not an issue if Jupiter and Saturn are only thousands of years old and not billions of years. Again, to remind you, that little white dot in the upper left equals 12,000 years. That's the maximum time any creationist model would allow. All those red dots of the same duration are needed to make just 1 billion years. So you have to multiply all of those by 4.5 times to see the difference in these two timescales. It's really hard for us to imagine and genuinely comprehend the difference in these numbers. So which is more credible? Jupiter and Saturn still generate more heat than they get from the sun after 4.5 billion years, or Jupiter and Saturn generate more heat than they get from the sun, but are only a few thousand years old. Let's talk about moons. Here are the 20 largest moons in our solar system in order of size. Moons with the blue arrows all belong to Jupiter. The white arrow points to our moon for comparison. So Ganymede and Callisto are a little bigger than our moon. Io is about the same size, and Europa is a bit smaller than our moon. So they're all in that range. So here we have those 4 moons plus our moon for comparison. Our moon has no volcanic activity. It's considered pretty much a solid rock. But Io, which is almost exactly the same size, has over 400 volcanoes. And of course, volcanoes require heat. And they are so much farther away from the sun, that should be impossible for a body the same size as our moon. Europa also is too smooth, has no craters visible because it keeps getting melted away. Therefore, it has heat, and it likewise should not have that much heat after that much time. Now, Ganymede is a little bit bigger. It actually has a magnetic field. And in order to have a magnetic field, the belief is that you have to have a molten core that is spinning to generate that magnetic field. That's impossible if it's that small and that far away in that cold of a region in our solar system. And Callisto has the most craters in the solar system. Now, all of those four all orbit the same planet. They should have roughly the same number of craters, but Callisto has way more craters than the other moons, and we don't know why. Remember the difference in time scales. 12,000 years compared to all of those dots being just 1 billion years, and 4.5 times that to equal the actual age that is proposed for our solar system. So which is more credible? Jupiter's moons with masses like our moon's mass, but so much farther from the sun, are too warm, but are still 4.5 billion years old. Or Jupiter's moons near our moon's mass are so much farther from the sun and are warm, but are only a few thousand of years old. Now compare the mean temperatures of Jupiter to Saturn. Jupiter's mean temperature is minus 166 degrees Fahrenheit. Saturn's mean temperature is minus 220 degrees, so a lot colder. Now, the Cassini-Huygens space probe explored Saturn and its satellites for nearly 20 years. It was dedicated just to explore Saturn, and it discovered a lot of things. For instance, Titan is Saturn's largest moon. It's about 9.5 times farther from the sun than we are, and there are some very strange things about Titan. Its atmosphere is made up of nitrogen, methane, ethane, acetylene, and other gases. And Titan's gravity is only 14% of Earth's gravity. Now, Mars' gravity is 38% of Earth's gravity. That's more than twice the gravity of Titan. And Mars doesn't have an atmosphere, and it's believed that's because it didn't have enough gravity to hold on to it. But here, Titan, with less than half the gravity that Mars has, still has its atmosphere. Looking on the right-hand side, we can see this is the view of Titan without the atmosphere in the way. The ocean, which is the light areas, are made of liquid methane and ethane. And the temperature at Titan's surface is minus 290 degrees Fahrenheit. If Titan is billions of years old, all of the methane should already be converted into ethane. And with so little gravity, Titan should have lost its atmosphere if it's billions of years old, but not if it's only a few thousand years old. Another thing the Cassini space probe discovered is that Titan is moving away from Saturn 100 times faster than it was previously thought. So if you wind that backwards in time, then 4.5 billion years ago, you got some real difficulties with Titan being that close to Saturn. Now, Titan is not the only moon on Saturn. Saturn has 274 moons in its orbit. It's more than any other planet, more than all the other planets put together. That would be bad enough if they were all rotating in the same direction. But 197 of the 274 moons are orbiting in retrograde orbits. That means that they're going opposite, like you driving down the highway in the wrong side, going opposite to all the other traffic. How would that even happen naturally? Saturn also has 77 prograde orbiting moons. This is bad enough for a planet only a few thousand years old, but it is just inconceivable that this could be going on for billions of years without those things all smashing themselves to bits and being maybe like the rest of the rings of Saturn, too much traffic congestion. So which is more credible? Titan has an atmosphere, moving away from Saturn too fast. Saturn has 197 retrograde moons and 77 prograde moons after 4.5 billion years. Or Titan has an atmosphere, moving away from Saturn too fast. Saturn has 197 retrograde moons and 77 prograde moons after a few thousand years. Let's look at the planets that are even farther out. You can see there how far out Saturn was, and you can see that the next planet is about twice that distance out. Uranus is way out there. Uranus has 63 times the volume of Earth, but only 14 times the mass and less gravity than that of Earth at 86%. And gravity is its heat generating capacity. Still radiates 1.1 times the heat it gets from the sun. That's how much heat it's giving off. That should be impossible if billions of years old, but not an issue if it's only thousands of years old. But another interesting thing happens with the moons of Uranus. The orbits average only about 10,000 miles apart. Now that sounds like a lot on Earth, but in space, with objects that have gravity and that attract each other, that's not very much distance. And some of them are as close as only 559 miles apart. And the orbits are at different speeds. That's so close that they perturb each other's orbits every time they're near each other. That's too close to have coexisted for billions of years. But it is possible for a planet that's only thousands of years old. So which is more credible? Moons of Uranus average orbits only 10,000 miles apart, some as little as 559 miles apart after 4.5 billion years? Or the moons of Uranus average orbits only 10,000 miles apart, some as little as 559 miles apart after a few thousand years. So we go even farther out into space and we find Neptune. It has 58 times the volume of Earth, but only 17 times the mass and only just over the same gravity as Earth, 1.14 times that of Earth. But it's radiating 2.61 times the heat it gets from the sun. And Neptune has the fastest planetary winds in the solar system, which requires lots of energy in spite of it being in the big deep freeze of our solar system. Again, that's impossible if it's billions of years old. Not to bore you, but there again, keep in mind the difference between 12,000 years, maximum amount of time in any creationist model, and all of those red dots still only equaling 1 billion years. You have to multiply that by 4.5 times to get what evolutionists say is the age of our solar system. So which is more credible? Neptune radiates 2.6 times the heat it gets from the sun and has the fastest winds in the solar system after 4.5 billion years? Or Neptune radiates 2.6 times the heat it gets from the sun and has the fastest winds in the solar system after a few thousand years. Back closer to Earth, we have rocks that were brought back by astronauts from the moon. And the chemical makeup of the moon rocks versus the Earth rocks has revealed something very different. The moon rocks have no water or minerals that form with water. Well, you would expect that since we haven't found lots of water on the moon. And the moon rocks have no volatile elements such as sodium, potassium, or zinc, which are found on Earth rocks. And some moon rocks have high concentrations of titanium and iron, which is not the usual thing on Earth. And some moon rocks are plagioclase feldspar, that is rare on Earth. So here is a summary that was published in Science Digest. To the surprise of scientists, the chemical makeup of the moon rocks is distinctly different from that of rocks on Earth. The difference implies that the moon formed under different conditions and means that any theory on the origin of the planets now will have to create the Earth and the moon in different ways. So again, we're finding out that this model of everything all just aggregating out from a big cloud of dust, it doesn't hold up with the evidence that we're finding. So which is more credible? Earth rocks and moon rocks are distinctly different, but still formed naturally from the same primordial cloud that all the planets came from? Or Earth rocks and moon rocks are distinctly different because they were separate creations, like all the other planets and moons. And since we're talking about the moon, it is now known with precision that the moon is moving away from the Earth at 1.5 inches a year. That doesn't sound like much. And 6,000 years ago, it would have been maybe 750 feet closer to the Earth, which is negligible. But 4.5 billion years ago, it would have been halfway closer to the Earth. That would have created tides from 10 to 100 times higher than we experience now on the Earth. And that should have washed away all of the continents. But we know it didn't happen because there's not enough ocean sediment. And not only that, there would have been really massive tectonic instability that would have basically destroyed the Earth. So the moon is known to be leaving at a set rate, and we can figure out that it can't have been that much closer than it is now. Otherwise, things would not appear as they do on the Earth. Which is more credible? 4 billion years ago, the moon was so close that tides would be 10 to 100 times higher, eroding the continents, but the ocean sediments don't show it. Or a few thousand years ago, the moon would only be a few hundred feet closer, causing no difference in tides. Let's look at the orbit of Pluto. Again, we know that Pluto is not considered a genuine planet anymore, but it was discovered in 1930 and it was considered our solar system's ninth planet until 2005, when it was demoted to dwarf planet status. After all, it is only 2/3 the size of our moon, and there are lots of other similar bodies in the outer reaches of our solar system that we don't consider planets. There was a special probe sent out to discover what they could about Pluto. It was the New Horizons spacecraft in 2015. And it found some interesting things that were not expected. The atmosphere of Pluto is 5 times thicker than was expected. We have inconsistent atmospheres in our solar system that don't make any sense. Earth has a diameter of almost 8,000 miles, and it has an atmosphere that's about 60 miles thick from the surface to what we would consider outer space. Mars is about half the diameter of Earth, and it does have a very faint atmosphere, but not much, and it only goes up about 6.6 miles. The moon is about a quarter of the diameter of the Earth. It is a vacuum. It has no atmosphere at all. But Pluto, which is actually smaller than the moon, has an atmosphere that's 25 miles thick. How does that make any sense? And not only that, Pluto has 5 moons of its own. They're very small, but they're there. All of these things are kind of strange. Not only that, the New Horizons spacecraft discovered that there were mountains on Pluto that are over 2 miles high, made of ice. Ice is not flexible. Ice is pretty rigid. To get mountains that high, there would need to be heat. And yet Pluto is so far from the sun, how would it get the heat in order to make those mountains and then let them get frozen? And then there are vast areas with no craters, which again indicate remelting and refreezing. And here is a picture so you can see what it looks like. There's some of the mountains, and there right next to it are some of the melted panels, they call them. That is very strange. In spite of the fact that it's way out in the outer reaches of our solar system, Pluto has very few craters, which again doesn't make much sense if it's been around for 4.5 billion years. But it's consistent with only being around for a few thousand years. So for a body that travels so close to the Kuiper belt, to not have any impact craters from all the chaotic bodies that are out there is inconceivable if Pluto has been around for billions of years, like we are being told. On the other hand, if Pluto is a unique creation that has only been around for a few thousand years, it's quite understandable. Cement in your mind the difference between the creationist timescale of the maximum of 12,000 years and the evolutionary timescale, which would be all of those red dots times 4.5. These facts that are verified by actually sending space probes to each of these planets show that the model of our solar system planet aggregating out of a swirling cloud of dust cannot explain what we see. But these phenomena are explained if we accept the possibility that these planets were created individually and are only a few thousand years old. Every time a space probe goes out, theories have to be revamped. Facts don't match the theory of naturally formed solar system or planets. But all space probe discoveries are compatible with a young Earth and a creation model. Now look at the scientific method. Make observations, ask questions, construct a hypothesis, make testable predictions. Does the data fit the predictions? If yes, you go on to develop a theory. But if no, you're supposed to come back and refine, alter, expand, or reject the hypothesis. And this is what the evolutionists refuse to do. The actual facts don't fit their theory, but instead of owning up to it, they dig in their heels and try to come up with outlandish ideas. The solar system origin model doesn't fit the facts, especially the 4.5 billion year time frame. But the facts do fit the creation model. And if the solar system and the Earth aren't 4.3 billion years old, evolution can't have happened. Remember the principle of Occam's razor. Simpler explanations are generally better than more complex ones. The simpler explanation is that these things are not as old as evolutionary theory demands, but people have been indoctrinated for so long it's hard for them to accept the facts. Evidence for individual creation and against natural formation. The planets have no progression in size, composition, or density. 3 of the 9 planets rotate different from the Sun or other planets. Uranus rotates at more than 90 degrees from the other planets with 28 moons. There's no progression or pattern to planetary axis tilt. There's no pattern of progression in planetary rotation speed. Moons with similar mass to our moon have vastly different characteristics. Saturn has 197 retrograde moons and 77 prograde moons. Rocks from our moon are vastly different in composition from Earth rocks. Pluto has less mass than our moon, but has an atmosphere. When you look at all of those things together, you can see that the evidence for creation is better than the evidence for natural formation. Remember, the theory of all swans being white, all you have to do is find one. We've found quite a few that refute that theory. Now let's look at the time frame. Here's the evidence for a young age against billions of years. The faint sun paradox. 4.5 billion years ago, Earth would have been frozen solid, and life could not have originated. Jupiter radiates more heat than it gets from the sun. That's impossible if it's that old. Saturn, more than twice the distance from the sun, radiates more heat than it gets from the sun. The biggest moons of Jupiter, with masses like our moon, are too hot and too far from the sun to have those characteristics, if they're that old. Titan, Saturn's largest moon, is moving away too fast for its claimed age. Saturn has 197 retrograde moons and 77 prograde moons, 274 total, spinning in opposite directions that can't have been going on for billions of years. Uranus, with less gravity than Earth, radiates too much heat for the supposed age. And the moons of Uranus orbits average only 10,000 miles apart, some only 559 miles apart. Again, that can't have been going on for billions of years. Neptune, which is 30 times farther than the Earth, has the fastest winds in the solar system. Our moon is leaving the Earth, and if it were as old as they say it would have eroded the continents, but there's no oceanic sediment to prove that. So again, you look at all these evidences against the billions of years. if the Earth isn't billions of years old, evolution can't have happened. So which one is real science? The data must conform to the theory if it does not adjust or ignore the data or the evidence? Or the theory must conform to the data if it does not adjust or abandon the theory? This is the first video in the series, and we have seen that the data does not fit the evolutionary model, and the data actually does fit the creation and flood model better. Next time, we'll look at the age of the Earth. So thank you very much for joining me. I really appreciate it.